Hello, everybody. Today we have a new MeteoTracker Stories. This is our first live in English. So today we have a wider audience than the usual Italian one we were used to have in the previous MeteoTracker Stories. Today we'll speak about weather data analysis and how they are used in weather forecast systems. And at the end of the life, we will launch the new Kickstarter MeteoTracker campaign. Our guests today are ELENA MAKSIMOVICH and FABRIZIO BAORDO. They will join us soon. To get started, I would say, Timoteo, we can show some video to present our product, MeteoTracker. Okay, so if you are ready, okay, here we go. The promotional video of
the climate is changing rapidly. It affects lifestyle. It impacts our cities, our landscapes, and our future. MeteoTracker is the first weather station designed to collect data on the move, combining this with a passion for meteorology, travel, the outdoors, and sport, all within a single user experience. Thanks to the patented technology of MeteoTracker, we can do more than you can imagine to monitor climate change and collect data in places and spaces that are meteorologically unknown. Keep your eyes on the climate. Support our project on Kickstarter.
Okay, so we have seen our promotional video, but I'd like to spend some more words about our product, some more technical words about our products. MeteoTracker is a portable mini weather station for data acquisition on the move. Therefore, it's not designed for stationary fixed use and has to be attached to a car or other vehicle's rooftop by means of its magnetic base.
We are ready for the video, we are ready.
Yes, we can show how MeteoTracker works by another video that Timoteo is going to share. Okay, here we go. So, this is you can select your priority level and then start your session. From time load, maps, real time are shown with a smartphone. These are the data that can be seen in real time. And as you can see, also paragliding is a field of application.
And we can also show now a real,
yes.
Usage, on a traveling car.
Yes, now we have another video that shows a real session, real world session. When Timoteo is ready, we can put it on the screen.
Showing how easy it is to use this device to collect weather on the move. Just one moment, it's loading. Okay.
Yeah, we have a problem with our...
Okay.
Here we go. This is the real life session, and maybe you are low resolution settings. Okay, so we are starting the session, and as you can see, the calibration is ongoing, and soon the acquisition starts.
So you are seeing in the screenshot of your smartphone weather data collected by the MeteoTracker that you just place it on the rooftop of your car. It's very, very easy to use. Okay, so we can go ahead and stop the video.
Okay. Okay, so Timoteo, maybe we can spend some more words about our patented system. Since one point of strength of MeteoTracker is its ability to remove the solar error. The error that typically affects the temperature measurement when the sun is hitting a measurement device. We have a differential dual sensor system, the REX system, radiation error correction system, that we patented in Italy, pending in other states and in other nations. And thanks to the REX system, we do not have to use a cumbersome and heavy shielding, but we can perform very accurate performances in a very small, compact shape and weight. Okay, I would say that it's time to introduce our guest, ELENA MAKSIMOVICH, PhD meteorologist and data scientist, and FABRIZIO
BAORDO.
Yes, remote sensing scientist at Danish Meteorological Institute. So, ELENA, you can introduce yourself briefly, and then we can proceed with some interesting question for you.
Mm-hmm. Hello, thank you, Yuri. Thank you, Timoteo, for inviting me today. And congratulations for this new phase in your project development. When I met you with this project, I was very inspired, and I'm more and more inspired every day. So I'm wishing you the best with this very modern and the project with a lot of potential. So yes, I'm a meteorologist. So I obtained my PhD in 2012 in Paris at the University Pierre-Marie Curie in meteorology, and specialized on satellite data processing and validation of satellite data with the combination of field measurements and field campaigns. Since 2012, I worked for French Academy of Science, CNRS, in several laboratories. And recently, since 4 years, I work primarily as an entrepreneur. So I'm implementing weather data, all kinds of weather-related data into insurance business, into hedge fund. So it's usage of weather data in real life conditions by industrial partners, let's say.
Okay, very interesting. So managing weather data is not simple at all, and it's a very huge field for study, and let's say has a lot of implications in real world, not only meteorology. Yes. But I would like to ask you, ELENA, in simple words, how the MeteoTracker weather observation could be useful in your field, in the meteorology and climatology field?
Mm-hmm. Thank you. Yes, so I have a lot of ideas on this subject, but I will just give you a few examples because we don't have much time, I think, now. But from the moment when I discovered your instrument, I had many ideas. So the two ideas which are not very obvious for most, let's say, industrial partners, but which are very, very let's say, up to date for the today business development, which are very, very important. The two ideas I see how your instrument could integrate the business applications. That the first could be drone safety operations, so drones in the cities, and the second application I see, which will be used widely not only in the cities and in all the countries. It's a usage for insurance contracts, for subscription, and for the follow-up of insurance contracts. If I have a few minutes, I will explain just very briefly.
Sure.
Sure.
Very interesting matter. Yes.
So regarding the drone operations, so it is already on the way since several years that the aviation regulation authorities of each country develop the rules, the flight rules, the flight operation rules for drone operations in cities. And for example, the most obvious case is operation of delivery drones, which will deliver parcels. So these drones, they have a limited time of functioning. They can work, for example, only for 1 hour, let's say, for the moment, what we have on the market. And they are sensitive to turbulence. So in cities, depending on the orientation of streets, there could be very strong turbulence. And also depending on the wind pattern, if wind is strong or not very strong, let's say the regional wind, some very dangerous conditions for drone operations can occur on different streets. So having a network of observations, even if it's, let's say for the beginning, if it's a temperature, humidity and pressure, it could be already a very good indicator of dangerous events for drone operations. So the regulation authorities, they will publish at some moment the similar rules as for airplanes. They will publish the rules for drones, in which conditions they can operate and which conditions they cannot operate, and maybe on which side of the street the drones should circulate depending on the direction of their trajectory of their trip, let's say. And also the other thing, so it touches right away. So from the moment when we have insured objects which are transported by drones itself have to be insured. So there will be not only the technical insurance for maintenance, but there will be, it's called parametric insurance. So depending on the conditions, on weather conditions, if drones cannot operate, okay. Then let's say the company the company owner or manager of drones, they will subscribe for insurance, so they will be refunded the loss during the period of time when they are not operating. So these are the applications.
And for example, in freezing conditions, it's not that easy to fly drone, right?
Okay, for the moment, me personally, I did not work exactly on the formulation of critical conditions for drone operations, but I mentioned that the temperature has an impact on battery usage. Also, temperature has an impact also on vertical turbulence. So in certain conditions, there will be too much turbulence. Or maybe some descending flows. Yes, these things that they will be formulated along the way, but they cannot start. Let's say they have a limitation that until there is enough observations in real time, until there is a true network of weather observations in real time. Let's say every 5-10 seconds, they will. Yes, it will be difficult. Let's say to operate drones. So let's say the drone operators, it will be one of the clients, let's say, as I see from my perspective, let's say, of clients, of consumers of the data coming from your network. And regarding the insurance, there is a huge potential, because insurance companies, they insure in areas where there are no when there are no weather stations. So and also the other thing that very often the data from weather stations is expensive or very difficult to get, because national weather services, they're not really equipped with the APIs where you can call the data. So the fact that you provide the API with the data, where whatever partner can get the data.
So there is a lack of massive weather data, let's say. So high spatial resolution data, which could be useful for many applications in many fields of human activities.
Yes.
Okay, very good. Thanks,
Very
Elena.
big lack.
Thanks, Elena. We'll come
So
back to
now
you.
let's talk with Fabrizio. Fabrizio, the Italian meteorologist with a lot of many years of experience abroad. So Fabrizio, tell you something about you.
Hi guys, I hope you can hear me okay. And first of all, thanks for inviting me. So it's a pleasure to be your guest. And yes, very quickly about me, about myself. I'm currently working as a research scientist at the Danish Meteorological Institute here in Copenhagen. And yes, my background is I studied physics, and then I got my PhD in remote sensing in Italy. But then I started to work in different places. Basically, I developed my experience in weather forecasting, weather modeling, and remote sensing application using different satellite data. And I work, for example, in Australia at the Bureau of Meteorology. I work in the UK, the European Weather Centre, the CWF, and I had also other experience. But that's my background. As Elena, I was, as well, really attracted from your project and your ideas and from this instrument, and possibly because, of course, there are, a huge amount of data coming from this new observation type. Let's say no observation type, observation instrument, and probably we are already in the big data era. So most likely, this kind of new data could be helpful for a lot of application, also in terms of, for example, machine learning or artificial intelligence algorithm. I'm not really expert myself in these topics because I'm just recently trying to get into, but I think that this could be, something also valuable for such as application.
Fabrizio, you are an expert in NWP, numerical weather prediction system. And we know that an essential part of this forecast process is data assimilation. What is data assimilation? I will ask you to explain it. My question is, how a numerical weather prediction system and how high-resolution data collected by a system like MeteoTracker, so in the move and with very high spatial resolution, may impact limited area forecast systems?
Yes, okay, so this is, let's say, complicated question to explain in 2 minutes, but
just
I mean, I know, but that's why I want to share my screen, because I prepared just a few slides to try to address and explain a little bit more in detail my opinion on the use or possible use of MeteoTracker observation in the context of weather forecasting. I'm not sure if you can see my screen and my presentation.
Yes, we can see.
Yes, so that's the question that I ask myself. Okay, when I start to hear about the MeteoTracker. Okay, so can MeteoTracker contribute to the numerical weather prediction of service system and improve short medium range forecast? Okay, so this is a very big challenge question to answer. And of course, we can address this question probably, because what we should do and what is done actually in the real life by the scientific community, using this observation within a forecast system, and the technique used is generally called observed system simulation experiment. But as I said, that's we can really answer to this question. But what I want to try to address in these few slides that give you the idea of the importance of the observation, and so the importance of MeteoTracker as a new observation system, is give you a very general overview of what it does forecast system and what is important, why the observation are really important in this context, and try to come up with a guess of why MeteoTracker observation could be helpful in this context. So very quickly, this is the overview of forecast system. So basically, what we on daily life, what we see, the weather forecast from our application, from the news, come from this massive complex system, which is really explained in a simple way. So on the top panel, we have the numerical models, which there are complex systems which try to explain the real world through physics parameterization. But this is not the only necessary part to have a forecast, because the big important part is also the panel underneath, the observation. The observation are a lot of different kind of, and observation are able to describe, are the only source to describe the real status of the atmosphere. And then there is this technique called data estimation, which is merging the numerical world with the observational world. And just through this process, you will have finally the as good as possible weather forecast that we receive today on daily basis. And let's see, to understand, in a schematic way, in a simple way, how many type of observation are up there to be assimilated in a weather model. Okay, of course now we try to compare MeteoTracker observation with what is actually already up there. Okay, MeteoTracker can be identified in that kind of category of observation, which is called in situ observation, and which of course are not satellite observation. Okay, and in situ observation, they are generally classified as those kind of observation that are taken by any instrument in direct contact with the medium it sends. So it means we have a direct measure of temperature, a direct measure of humidity, and so on. While satellite, most of the time, they don't measure directly these things. And here, this panel, this plot on which I got from the CWF webpage, is actually all the observation, surface observation, this in situ observation that are spread across the world. And you see a lot of points, but if you think about this globally, you can see the total number of observations is 120.
Fabrizio, yes. In the maps on the right, we are seeing all the source of weather data that are yes. being used for forecast weather system, correct?
Yes, correct. This is the actually surface observation, or also on board of this, which are currently used by the global model, for example, in this case, the CWF system. But what I want to point out that this seems a lot of points, okay? But you have to think that this is a stationary points, and probably between the distance between one point and another could be even 50, 100, or even more kilometers, okay? But you can also work out that there are a lot of white spots. It means there are regions across the world where there are lack of observation. And if you zoom, for example, this is Sardinia, of course. If you see, there's an image coming from the MeteoNetwork.it. You see that if we imagine we have yes, imagine we want to have a high resolution limit area model, forecast model nested over Sardinia. You see that probably you can assimilate just few observations in some spots, okay? And so you don't have a really full coverage observation. So this is just to try to give you, a kind of sense of the importance of observation. We can cover completely different part of the globe. And in this example, I want to also point you out. These are the web page, okay, where I think this web page is gonna open, okay. This is I highlight this.
That's a very interesting point, Fabrizio. Yeah. Yes.
I want to go at the very top because probably you can see the the title, Drop in Aircraft Observation Could Have an Impact on Weather Forecast. This is dated 24 March 2020, because when the lockdown starts everywhere in the world due to the coronavirus, the SynWF start warning to put this warning that most likely the weather forecast would have dropped in accuracy and skills, because this is what's directly connected with the lack of observation. And so you can, for example,
worse weather prediction due to less data from aircraft.
Correct.
Due to the lockdown crisis that stopped many of the flights. Okay. Very interesting.
Here you can see the drop in number of observation. I mean, this is a web page, so you can see. And this is a nice plot, because you see that before the lockdown, that's the common coverage. And then this is actually during the lockdown phase. And this plot is dated, the first panel is 2 March 2020, at the bottom panel is 23 March 2020. And here you can, also have an estimate. The first three green lights was a light. Now I missed them, but they should stay here somewhere. Just to quantify, sensitivity study has shown that removing all the aircraft data, the greatest short-range winds at temperature forecast at those level. Those level is this level in the altitude. By up to 50%. That this is a big, huge drop. So this is just to give you the feeling of the importance of observation and using the weather forecasting. And the last slide is my opinion of what we can expect from MeteoTrack observation. The first points, I guess, is pretty much obvious, because of course, with some network, we can improve observation density in location where coverage of in-situ observation are poor. And then there's these points that, of course, needs to be demonstrated, as I said at the very beginning, with more accurate scientific studies through the OSSE experiment, the OSSE experiment. But what we could expect in that kind of data simulation, that of course is not simple to implement, because we have to take into account to do a quality assessment of the observation error, other things which are necessary to come up with a forecast system. But let's say that we will be able one day to perform such an experiment. What we could have out of that is possibly improving in mesoscale weather phenomena. And then the I-space and time resolution may be valuable for nowcasting. What I mean for nowcasting? Improving representation of frontal system, for example, having better wind and temperature prediction. This could be a benefit, for example, for energy companies. And then also improving representation of convective cases. This means that we can maybe better represent intense precipitation events. And of course, this would help in terms of, for example, warming systems. So this is, of course, just few ideas, and it needs to be, of course, validated and studied in much more detail. But this is what I wanted to share with you.
So the issue is the same as ELENA said before. So the lack of high-resolution data, which impacts also the prediction system, apart from all the other human activities. Okay, we are running out of time, so I would like to ask to put a last question to ELENA. ELENA, we know that you you did a lot of study about Arctic climate. So what could be the potential of MeteoTracker weather sensor in rough continental, very cold Arctic polar conditions?
Thank you for this question. So in fact, I spent a lot of time in the polar conditions, and first, information to know that over thousands of kilometers in the polar regions, there are no weather stations at all. So there's a true lack of like a desert, observational desert. And when Fabrizio showed his maps, it was exactly the footprint of there are very few observations, and it's also many people maybe they don't think about it, but in reality, I would highlight that these very cold areas in the polar region, especially the Arctic, in these areas there's a very heavy industrial activity, so oil and gas extraction, natural gas extraction. There is also a question of shipping, how to transport oil and gas, and there is a question of monitoring the pipes, the oil pipes, to survey thousands of kilometers of oil pipes, and there are roads along these oil pipes. So from the point of management of shipping, so there are also very big rivers in the Arctic, very large river. And on these rivers, it's for example during winter period, it's very important to have a thick ice, and the transport of trucks on the ice is cheaper than transport of ships. So there are sometimes limiting conditions between whether it's a ship should be transported or a truck on the ice, or the truck. So having this network in the Arctic, in both in Alaska, in Canada, in Russia, in Norway, in Sweden, would allow for better management, yes, of transport of oil and gas transport, how to ship them, with which means, and there's also the industries to make liquefied natural gas to reduce the volume. So the energy necessary to liquefy the gas depends on the outside temperature also. So there are losses, there are big financial losses related to this activity. So having the instrumentation for each member of the industry would be very, very useful in real time, and easy to implement. And let's say the price of the cost of the production, the price of your instrument is very, very attractive for such business.
So these regions have a very low number of meteorological stations, so
yes,
they cannot monitor at all for hundreds and hundreds of kilometers. What I'm sharing now is a session we did in Alaska, or better, one of our tester, Vladimir Alexeyev, which is a collaborator in your activities, ELENA, right? Correct?
Yes.
Yeah. Okay. So this session shows how how extreme can be the Alaska data, but I'm not referring only to the absolute value, which is in this case minus 28.7, which of course is a very low temperature. But maybe the most relevant aspects is the temperature variation in a very short range. As you can see, we have in this area minus 14 degrees. I can enlarge the monitor so that, just a second. So we have here minus 14 degrees. While few kilometers apart, we have minus 28.7 degrees. So more than 14 degrees of difference in maybe 7 kilometers. These are 5 kilometers here below. So which is really two different worlds in terms of temperature. So this, as you can see, also the graph is very clear as far as temperature variation is concerned here. So it's just an example of how the current fixed weather station is not able to characterize correctly the climate of a region. Timoteo, now we are about to launch the campaign. Would you like to add something, or last question, or if there are any questions from the audience, we can answer through the comments.
This is the first time that we made a live in English, so hopefully friends from US will reach us by this live. We know the product, and we help us also spreading the system in US, Canada.
Okay, guys, so maybe it's my turn to share the screen, since, as you probably know, we are going to launch a new Kickstart campaign. We did a previous a campaign some weeks ago. We didn't get the target, so we planned and managed to prepare another campaign. And today is the day of the launch. And you know, it's very important for us to have as many bakers as possible, since we want to go into production as soon as possible. The more the bakers, the faster will be the production process. We need to assemble the PCBA, the mechanical parts, to perform the certification for electronics, and other fixed costs that need to be financed. So let me share the screen, and in few seconds the campaign will be live, and everybody could make its pre-order on Kickstarter. So okay, let me change.
We are very close to start the production. The product is ready. It's not an experimental project. It's a real life product with 100 samples collecting data around the world. So it's not.
Prepare to launch. We are going to launch the campaign. Okay. Launch now. Shall we launch, Timoteo? Again. Congratulations, our project is live. So now it's your turn to back this project, and we hope we can deliver as soon as possible our MeteoTracker portable weather station for data acquisition on the move. I would like to thank our guests. Thanks, ELENA. Thanks, Fabrizio, for your precious contribution to our MeteoTracker Stories. I think that we should organize a webinar focused on these topics, because today we had to, let's say, sacrifice a little bit the complexity of the matters, but with the right time we can really have a nice presentation of this very fascinating field in meteorology. Okay, so
thank you. Good luck for this project.
Yeah,
we have the first baker. We have the first baker
in the future. Yes, to continue.
Okay, so thanks, guys. Thanks for your time, and see you soon, I suppose. Bye. Ciao a tutti, grazie per averci seguito.
I trust it will work out very well. Good job.
Thank you. Ciao, ciao, ciao. Grazie.
Thanks, guys. See you soon and good luck.
Ciao.